This is a very interesting depiction. You can see the sun. In our galaxy, our sun gives us everything. Whether it's a plant or a bird, all forms of life depend on the energy from the sun. In fact, sunlight creates life. It creates and it destroys. In many of our cultures, we revere sun as God. And we all know that our philosophy teaches us the importance of sunlight in our life. This is a very interesting painting that you can see here. This is the Fountain of Youth. It's a late Renaissance painting by Lucas Cranach the Elder. You can see an interesting well here, the so-called Fountain of Youth. And then you can see the statue of Venus and Cupid. And you can see old people driving there in harsh environment, jumping into the well and converting into beautiful young people. The quest of mankind has always been Harry Potter's Philosopher's Stone. In other words, we all don't accept the passage of time. Chronological aging, falling sick, becoming old and dying, in fact, is the greatest gift of God, and not eternal youth or eternal wealth or eternal health, which is actually a dangerous thing to aim for. So, what is time? This is a very, very great, I would say, metaphysical question. And this is a very simple way of depicting it. A patient comes to us, "Doctor, can you make my skin look 20 years younger?" The dermatologist says, "Sure, we will just move you to a dimly lit room." Two major philosophies here. First thing is perception or consciousness. We perceive everything through our sight and judge beauty. And this perception depends on light. So let's get into the physics of light, photobiology and dermatology. It all starts in the core of the sun. You know that the core temperature of the sun is 15 million degrees Celsius, and you have nuclear fusion happening there. Literally, a huge amount of photons of heat are released, and 600 million tons of hydrogen is converted into helium every second. The energy is released as electromagnetic radiation. So you can see here a depiction of deuterium and tritium forming helium, and then photons starting as high energy gamma rays undergo billions of collisions. Journey to the surface takes thousands to millions of years and is released as visible light into the photosphere. There are four fundamental forces in nature: the weak nuclear force, the strong nuclear force, gravity, and electromagnetism. It is electromagnetism that we are primarily interested in today, and it's all about a force which is much stronger than gravity, having an infinite range, stronger, and governs all atoms and chemistry. So all chemistry is governed by electromagnetic force. This is a more recent concept of the structure of an atom. The core of an atom contains protons and neutrons, that is the nucleus. It is surrounded in various orbits by the electrons. Interestingly, the nucleus, that is protons in red and neutrons in blue, are made up of quarks and gluons, and the electrons form probability clouds or quantum orbits. We are far beyond Niels Bohr's theory of the structure of the atom. We know that electrons spin in quantum orbits. The orbitals may be spherical, dumbbell, or multilobated. And quantum mechanics explains the spectra, bonding, and the periodic table. So all chemistry is dependent on the photon or the electromagnetic force. So to make it very simple, what happens? An electron is supposed to be in a fixed orbit around the nucleus of an atom, which is based on the energy level. Now, it can absorb a photon or it can emit a photon. When it absorbs a photon, it moves from a low energy orbit to a high energy orbit. And when it moves from the high energy orbit to back to the low energy orbit, which is its nature, it has to emit a photon. These are the two most important phenomena we need to understand. And the real life importance is that it explains everything like neon light glowing, how lasers work, light detection by our eyes. This is the basis for most of photobiology. A depiction of the same again to show you that the photon absorption and emission is central for the radionuclear electron spin in MRI, infrared bond vibrations, visible electron transitions, UV and X-ray ionization. All chemistry and life depend on the atom and the electromagnetic force. Very interesting photo again. The red one is the positively charged photon and the blue one is the electron. So when two electrically charged elements interact, they interact by photons. It is the photon which interacts between the two, and this creates the electromagnetic wave. The electromagnetic wave is both electricity and magnetism, which spins, and it has an infinite range. And just to have a small interlude to make it a bit more interactive, how many of you like potato chips? How many of you like hash browns? How many of you like French fries? So what are we all talking about? They are all potatoes, isn't it? So electromagnetic radiation is all potatoes. In other words, whether you are talking about gamma rays or X-ray or visible light, ultraviolet, infrared, it's all the same potato. The difference, whether it's a hash brown or whether it's a French fry, is it depends on the wavelength and the frequency. That's all. Basically, everything is the same potato. So, in early 1930s, Michael Faraday invented the concept of electromagnetic fields, and Maxwell's equations are groundbreaking. And he is the person who actually showed us that the electromagnetic radiation goes as waves. And Hertz confirmed this wave, and he showed it also, demonstrated it. So this is the electromagnetic wave. The wavelength is the distance between two peaks of a wave, described in meters or nanometers, and it determines the color. So in other words, whether it's violet, whether it is blue, or whether it's yellow, or whether it's red, is going to be based on the wavelength, which is the distance between the two peaks. The frequency is the number of waves per second in hertz, which determines the energy. So the relationship goes like this. C is the speed of light. You have the lambda V. Lambda is the wavelength, and V is the frequency. And the photon energy can be calculated by E is equal to hV, where h is the Planck's constant, and V is the frequency of the wave. So is it a wave or is it a particle? This is very, very interesting, and I would say that if you consider it as a wave, the electromagnetic spectrum, light is a part of it. UV is 100 to 400 nanometers. It determines photochemistry, DNA damage, vitamin D synthesis. Visible light is 400 to 700, vision, photodynamic therapy, and infrared determines thermal effects and infrared imaging. Everything in this world, all life emits light. We emit light. Can we see light coming from any of us? No. Why? Because it's in the infrared spectrum, which is not visible to our eye. The eye can detect a very, very small portion of ultraviolet radiation, and this is the solar spectrum. And you can see that visible light is a very, very small part of it. In fact, if you look at this, the shorter the wavelength, the more power it packs. So cosmic rays, gamma rays, X-rays, they all have very short wavelengths. In other words, they are very powerful. An X-ray will penetrate our body. If you expose yourself to X-ray for a long period of time, your body will be damaged. Even your internal organs will be damaged. You will end up with internal malignancies. That's why when we go for an X-ray, the technician will shield himself in a lead room and expose us to a few milliseconds of the X-ray. Of course, when you come down, UV radiation, again, the wavelength is shorter. So it packs a punch, it comes. Only thing is, you see here the terrestrial sunlight spectrum. What is terrestrial sunlight spectrum? When this sun emits electromagnetic radiation, before it reaches our atmosphere, it shows cosmic rays, gamma rays, etc., etc., etc. But our atmosphere permits us to live by shielding us from many of these rays, and even the ultraviolet C is by and large prevented from reaching our skin. What we get is UVB, UVA, and then you get the visible light, and then you get the infrared, and a little bit of the radar and television waves. See, this is the spectrum of ultraviolet. So UVC, UVB, A2, A1, and visible light. So UVC is germicidal and it is blocked by ozone. UVB causes burn, B for burn, DNA damage and vitamin D synthesis. UVA2 causes pigmentation and DNA damage. UVA1 has a deep dermal penetration and causes photoaging. A for aging, B for burn. B can be blocked by glass, window pane. B can be blocked by the 3M of the screen we put in cars. But A cannot. A penetrates. B reaches only our epidermis. A goes even up to the dermis. It all depends on the wavelength. And then infrared goes even deeper. So we need to understand multiple things. One is that depending on the wavelength, you determine the color. For example, violet is 400 to 450. Blue, green, yellow, orange, red. With Gaia. So violet has the highest energy. The shorter the wavelength, the higher the energy. Blue, green, yellow, orange, and red. So the unique features. A photon is not just a wave, it's also a particle. And it has zero mass at rest. It doesn't have any mass, it doesn't have any weight. So we all know that physics can be classified basically into four major groups: mechanical physics or Newtonian physics, electromagnetic physics, the relativity physics of Einstein, and the quantum physics. Okay? So when you talk about the mechanical physics, what is weight? Weight is mass times acceleration. This has zero mass, this has zero weight, but it can be affected by gravity. This is very interesting because a photon, all electromagnetic waves travel at the speed of light. That's a constant which Max Planck clearly demonstrated. And this constant is unique because this constant means that there are two things happening. One is classical physics. In an inertial frame, all classical physics behave similar. And the speed of light is a constant, which means all things that we see are illusion, are Maya. In other words, space and time are a construct of gravity. And the speed of light, which is approximately 300,000 kilometers per second, literally determines time. That's the interesting thing about the first photograph you saw about the chronological aging. Is aging really happening in this universe? We don't know. If you travel at the speed of light, you stay at age 0. So a lot depends on what speed you are traveling at. Wave-particle duality is a very interesting thing. And the energy and momentum of the photon can be calculated easily. It's literally an immortal particle. Of course, it can bounce, it can reflect, so many things. The photoelectric effect. If you send photons and strike a metallic object, depending on the quanta and frequency of the photon, you can eject electrons from a metal. This is what Einstein showed. And this proved that the photon is a particle and not a wave. So how can it be a particle and a wave at the same time? So if you do the double slit experiment of Young, you can demonstrate the wave-like particle behavior of a light. And if you use an observer or consciousness comes in, it collapses to a particle behavior. So everything depends on us, the observer, and our method of calculation of this observation, which actually proves that an electromagnetic wave is a wave or a particle. Particle behavior was clearly shown by Einstein's photoelectric effect, and currently we view everything through the quantum lens. Photons are quanta of electromagnetic fields, where wave or particle depends on the way you measure it. Of course, wave, interference, diffraction, polarization, reflection, refraction, dispersion are all wave properties. Particle properties, photoelectric effect, Crompton scattering, black body radiation or Planck's hypothesis, photo detection and gamma ray production. So, if you look at Niels Bohr's atomic structure, many interesting things or key concepts of photobiology can be understood. The key concepts are that discrete energy levels, in other words, everything works in quanta, depending on the movement of an electron from one orbit to another. The quanta of energy released differs. So molecules in skin absorb specific wavelengths of light, and this energy can cause UV-induced DNA damage and melanin absorption. All chemistry depends on the photon movements. Quantum jumps, photon absorption by molecules excite electrons, leading to photochemical reactions like vitamin D synthesis and fluorescence. The wave-particle duality, light can behave both as a wave, which means it can penetrate the skin, it can cause diffraction, and as a particle, causing photon energy, which explains phototherapy and laser action. The clinical applications are wide: narrowband imaging for psoriasis, vitiligo, UVA for depigmentation, blue light for acne, lasers in dermatology. You have any number of things. There's an interesting cartoon that ChatGPT made for me very easily. A conversation between Niels Bohr and Einstein. So Niels Bohr says, Einstein, your photons explain how light excites electrons, but they also explain why UV light excites too much skin. And Einstein replies, true, your energy levels are even more useful. They show why skin cells react differently to UVA, UVB and visible light. So this wave particle duality of a photon and the energy or punch it has and the wavelength determine to what depth it enters our skin and what kind of chemical reaction it can cause. So dermatologists should thank quantum jumps for tanning and for sunburn. Obviously, yes. Yes, for yes, and for sunscreen too. Without quantum theory, we wouldn't know how molecules absorb harmful radiation. So sunscreen theory itself depends on the quantum effect. Then photobiology is proof. Physics is not only explaining the universe, it also explains why people buy SPF 50. Very profound equation, I don't want to go into it. Maxwell's four major electromagnetic equations which predict electromagnetic waves, which basically showed that the speed of electromagnetic radiation is a constant, the speed of light, 300,000 kilometers per second. And the postulate of Einstein, that Einstein thought if this is true, if what Maxwell says is true, that all light travels at a constant speed, then Newton was wrong. That means Newtonian physics is no longer relevant. Everything has to change in our mind. That means if you accept that the speed of light is a constant, then time can change, length can change. So you get interesting concepts of relativity like length contraction and time dilation, which leads to our profound understanding of the illusion or Maya of this universe. So all this can be explained by his profound equation E is equal to mc square also. So light is an electromagnetic radiation, the photon energy are based on the quantum theory. Interactions with the skin include reflection, absorption, scattering, transmission. You have the various wavelengths, even visible light and infrared have effects on the skin. And the most important relevance for us is phototherapy, lasers and IPL, photodynamic therapy, sunscreens, and using light in wound healing and cosmetic dermatology. So photodermatology basically deals with these areas. Photosensitivity in abnormal skin reaction to UV or visible light, which can be idiopathic, drug-induced or metabolic. Phototherapy, which is a controlled exposure to ultraviolet light as a therapeutic modality. Photodynamic therapy, where you use photosensitizers with light, resulting in reactive oxygen species being released with selective destruction of abnormal cells, mainly malignancies. Laser therapy, where you make a monochromatic coherent light for selective photothermolysis and its uses, and of course sun protection. Photosensitivity is a very common issue that we face, and an abnormal cutaneous reaction to ultraviolet light or visible light resulting in an exaggerated or atypical skin response. We see rosacea very frequently. We see chronic actinic dermatitis very frequently. We hardly ever see malignant melanoma or many of the malignancies. So photosensitivity is a more commonly encountered entity, especially in Asian skin. And it's something that we need to tackle, and it can be either exogenous or endogenous. So exogenous can be phototoxic or photoallergic. Endogenous can be because of porphyrias, DNA repair effects like XP, many of you know it, and connective tissue disorders like lupus. Of course, it can produce acute or chronic reactions, acute being the burns, chronic hyperpigmentation, lichenification, actinic damage, and of course distributed in sun-exposed areas initially. Sunscreen is a very important component of any kind of photosensitive disorder that we may be talking about. Photobiology, I think I will skip this slide. And polymorphous light eruption is one of the commonest things we see. Chronic actinic dermatitis is quite a nightmare for many of us. Phototoxic and photoallergic reactions are not uncommon. Tetracyclines, thiazide diuretics, we need to be very alert in taking our history to be aware that a medication might be causing a photoreaction. And lupus, of course, and solar urticaria. These are the common things that we see, not the malignancies. Of course, phototherapy, therapeutic use of ultraviolet light, immunomodulation which suppresses pathogenic T cell activity. So ultraviolet light, when it reaches the skin, whether you are talking about PUA or UVB or narrowband UVB, can have apoptotic effect on the keratinocytes, can have an immunomodulating effect on the T cells, and can have alteration of the cytokine profile via melanogenesis. So we use broadband UVB, narrowband UVB, PUA with Soralen, UVA1, and we know the conditions where they are used. We need to know that every time you use a phototherapy unit, you need to calibrate it, understand what spectra we are actually talking about, understand the indication, the contraindications, the setting, the dosimetry, and how we are going to use it, and how we are going to counsel a patient on how to use phototherapy. Photodynamic therapy, two-stage, you apply a photosensitizer to the skin and then expose to ultraviolet light, and it causes selective phototoxic or cytotoxic effects. Photosensitizer accumulates in the target cell, and when you expose it to specific wavelength, it can destroy the cell. Most commonly precancerous lesions, skin cancers, even in acne we use blue light with the photosensitizer. Malignancies, the only thing about malignancies is that you should know which type of skin you deal with. In Dubai we may come across any type of skin, but in Asian Indian skin, squamous cell carcinoma is the commonest, not even basal cell carcinoma. So it is the tobacco and the tobacco that we use which causes cancer maximum in Indians than anything else, and maybe the HPV. When you talk about malignant melanoma, you need to know that you have a combination of three things. One is genetic predisposition, especially type 1, type 2 skin. Second is photo aggravation, especially during childhood. Bursts of intense exposure to ultraviolet light during childhood. A family history of melanoma. And the last thing is specific types of lesions. For example, a giant melanoma in a child is more prone to become malignant, or if you have multiple moles in a person and one looks different, ugly duckling. So you need to remember that environmental exposure, phenotype, And genetic and familial factors need to be always considered. Yeah. ChatGPT flow chart showing you about the role of not only light but the genetic factors in malignant melanoma. Similar chart showing that basal cell epithelioma also is induced by light. And here to show you that in squamous cell carcinoma, it's not just the light, but it is the carcinogen which is also required to cause the tumor. So effects of light can be useful, harmful, acute, chronic, and sun protection is very important, whatever be the effect. And Einstein showed with his photoelectric effect how a laser can be made and how light and heat can be transferred. And the key properties of laser light are that it is monochromatic, coherent, and collimated. What do you mean by monochromatic? Single wavelength, one color of light. It should be a single wavelength, all the waves. What do you mean by coherent? Light waves are in sync in phase in time and space. So in Einsteinian, this one, it should be in sync in time and space for it to be coherent. Collimated means they are parallel with minimal speed and divergence. So how do you make a laser? You need an element which should be triggered to induce a laser to be formed. You should channelize it and use a machine with lenses and mirrors which can actually propagate it. So it's as simple as that: monochromatic, coherent, collimated, dermatological lasers, a device that produces a monochromatic, coherent and collimated light. In dermatology, lasers target specific skin component called chromophores, which absorb it. You can have melanin, you can have hemoglobin, you can have water, and you have the various types of dermatological lasers, and most commonly used for hair removal, pigment lesions, vascular lesions, tattoo removal, skin resurfacing, and irrigation. Look at the spectra of lasers. It extends right from UV to even infrared. So don't think that laser is not visible. It is visible. There are visible light lasers and infrared lasers also. And everything depends on our understanding of the engineering, the parameters we set, and the safety precautions of a laser. Engineering core component: Nd:YAG, dye, semiconductor, gas, pump source, optimal resonators, cooling systems. We need to understand the wavelength, the pulse duration, which should match the thermal relaxation time of the target. And what we mean by fluence, spot size, and cooling parameters, and safety, of course. So lasers are not very complicated, very simple stuff only. And I would say that the conclusion is that Einstein talking to Max Planck, the Planck constant is one of the most interesting things in physics nowadays, which opens the door for quantum physics for us. And Einstein says, well, I just showed that photons knock electrons out in discrete packets, which are based on Planck's constant. Classical physics says light is a continuous wave. Classical physics gave us sunlight, but quantum physics gave us sunscreens. SPF is the time machine you can actually buy over the counter. So you all know that for example, in the Tibetan monasteries, there are some people who enter the cave as youngsters and come out when they are 60 or 70-year-old. They look like kids. Their skin is clearly like a pediatric skin. Sunlight is one of the most important things which causes photoaging. So SPF is the time machine you can actually buy over the counter. Whether a person has a photosensitive disorder, whether a person is worried about aging or malignancy, whatever it is, we need sunscreen, and we need sunscreen at all ages and all races. So it can't stop time, but it can slow it down. And skin aging is nature's way of reminding you that SPF is cheaper than Botox. Why don't you put a sunscreen right from birth rather than bother about Botox, which is a shortcut, which is short-lived? So sunscreen is something that we all need to know about and we all need to use. I will rest my case with this slide. This is our philosophy. Tattvam Asi. You are that. Thou art that. Which means We are what it is, and what it is what we are. And this sunlight, which gives life to us and ends our life also, is the cycle of the universe, and that is Tattvam Asi. Of course, I would like you to subscribe to my YouTube channel. Thank you very much.
Thank you, Doctor, for your wonderful speech. So initially, I told Dr. Srinivas that we did a short discussion regarding the sun and everything. But he said that it is not a small subject, it's a big subject.